Today, our topic is actually completing the square. So I'm going to be writing that out. And so this is a math topic that I feel has received not as much love as it necessarily should in regards of its practicality. And oh my gosh, I'm doing a Freudian slip, I guess, because I was saying of, but um, completing the square. So this is something that you may have heard of in your algebra classes. It's a form of factorization. So by factorization, I mean if we have a polynomial, specifically with completing the square, it refers to quadratic polynomials. So that means that we're in the form a squared plus sorry, that's not what I mean. A x squared plus bx plus c is equal to 0. So when we have a polynomial in this form, then if you maybe remember from your algebra class, a polynomial of order 2 has exactly 2 roots. This means that there are 2 numbers we could plug into this equation that would make this equation true. So if we, which means this whole deal over here would equal 0. Now, in a usual situation, people tend to fall back on the good old quadratic formula, which I will write out here because it has been ingrained in my memory. B squared minus 4ac all over 2a. This is a very useful formula because you can get both answers fairly quickly, and you can just plug this formula into your calculator. It'll do all the work for you. And it will also give you normal factorization. So it doesn't have to be just if there's a weird situation where you can't factor it in your head. This will give you any of the roots. So it always works for quadratic problems. But there's actually another way you can do this. You can find the 2 roots of a quadratic equation, and it will always work. And so that method is called completing the square. And in the end, it ends up being about the same thing. But this formula is just sort of a shortcut. And the reason that I like completing the square is because it actually gives us a way that we can do this fairly quickly in our head without having to keep track of all of these radicals and all of this large fractions. So I'm going to clean this up here, and we're just going to go over the actual method of completing the square, just for those of you that are either learning it now or are trying to freshen up on your algebra class. So we will rewrite our form here, ax squared plus bx plus c. So there is a special form that a quadratic equation can be in that is very nice for us to work with. Sorry, the dog's trying to get into the room, so we're going to let her in here. But yeah, so there's a special form that a quadratic formula can be in that's very nice to work with. And the reason for this is that if we have this, we can, if we have a quadratic formula in this form that I'm talking about, then we can say that this is equal to our variable x minus some constant. I'm just going to say z just for now. And this whole thing will be squared. And so what this formula is what form that the quadratic formula needs to be in, or the quadratic polynomial needs to be in, is the form x plus 2z and then plus z squared. So actually, I believe that if I have, we're gonna say this is a plus. So if we work this out, then this should make sense. We can just FOIL this out. So this is x squared. So x squared is our first term because x times x, and then x times z plus z times x is, sorry about that, I'm just messing up the form, but we're going to be getting the correct answer. And this is why you always check your work, kids. So we have our 2zx and then our z squared. And so this is the form we want to be in. So completing the square works on making this form out of what we already have and then dealing with the rest of the numbers later. So what we can do is our first step is we want our x squared term to be by itself, to be multiplied by 1, as opposed to this a. So what we're going to do is we're going to take our form here, and we're going to say x squared, and we're going to just leave the a off, because over here we're going to say bx divided by a, and then we're going to say plus c divided by a. So once we've done this, we can start working with how we want to figure out this formula. And what you're going to find is this should equate, when we use the symbols, back to the quadratic formula. So if we have our x squared here and we have our c over a, what I'm going to be doing now is I'm going to actually, I think I'm going to just give you an example to show how this works, because I think with all the symbols it might get a little confusing, and perhaps we can go back and do that in a later time. So first off, I'm just going to give an easy example to work with. So we're going to say x squared plus 2x plus 10 is equal to 0. The reason that I chose this, you'll probably see in a second, but there's a lot of factorization that goes along with this that should work out pretty easily. So what we want to do is we want to get this in the form we were talking about, where we have x squared plus 2 times some constant times x plus our constant squared. So what we have now is x squared plus 2 times 1 times x, if we want to consider it that way. So I'm going to start writing this out. Plus 2 times 1 times x plus, and we want to have our constant squared in the next term. So we have a 10 here, but we want to find what we need to take out of this 10. So if we have 1 as our constant that we're working with, then we are going to subtract 1 from this 10 and then move the rest of the 10 over to the other side. So we have our 1 that's left over, because that 1 is 1 squared, and then we're going to have a negative 9 over on this other side. And so if we have this equation, then it is now in the formula that we need, and we can say that x minus 1 squared is equal to negative 9 in this case. Now, we will have a negative under the radical, but we'll just leave it for now and ignore the imaginary numbers in this work through. If you guys want me to do a video on imaginary numbers, I'm sure I can whip something up. So now we want to solve for x. This is what we're doing. So we have our x squared, x minus 1 squared is equal to negative 9. And so what do we need to do next? We need to get rid of this squared. So we have to do the square root of both sides. So we are going to have x minus 1 is equal to, and now this is something that a lot of people forget, it is plus or minus the square root of negative 9. And then all we have to do now is move this 1 over to the other side. So we have 1 plus or minus the square root of negative 9, and that is our answer. Now you could say that this is 1 plus or minus 3i if you wanted to. Okay, so one thing I will mention, and I'm going to go back to where it was at, is that there is another way that people sometimes do this. It doesn't change anything. It's just sort of a preference thing. So if we start back with our x squared plus 2 2x plus 10 is equal to 0. There are some people who would say after that step that they would move this 9 not to the other side, but they would keep it here. So they want to do this 1. So this is an x, and this is a plus sign. They would put this 1 here, and then they're going to say plus 9 is equal to 0. And so this is just a preference. It keeps everything sort of in the same shape, but then we can see that we can do the same thing. So from here we would have x minus 1, x plus 1. I think I did minus on the other work through, but it is plus 1 because that is what would be needed to multiply this out. So x plus 1 squared plus 9 is equal to 0. And you can do the same thing. You would just move the 9 over at this point. Or you can do, so you'd have to move the 9 over in order to do the square root of both sides, or else it would get a lot more confusing, and I don't think we would want to get into that. And before I move on, I do want to mention, so I kind of touched upon this at the start of the video, but completing the square is a very, it's a very useful method for factorization when you're doing things in your head, because you can easily make the factorization into a form that is that you already know the answer to. So I just want to reestablish this again. So if you have something simple like x minus we're just gonna pick random numbers. So we're gonna say 4x and let's put a 2 there and make this an 8 just so I can reestablish what the original, what the actual total idea is. So we're going to say 8 plus, I don't know, 24 is equal to 0. Then this can be very easily manipulated. Sorry, this is x squared. This can be very easily manipulated in your head. So all you have to do is divide everything by 2. X squared minus, so 4x plus 12, that's an x, and is equal to 0. So this was an easy problem because I set it up that way, but then all you have to do is divide this number by 2, and so actually we'll go step by step. So we're going to say 4x is equal to negative 12. I keep picking the negative numbers, but and then all you have to do is add a positive 4 to both sides. So then we have our x squared, sorry, not x squared there, x minus 2 squared is equal to our plus 4. That's going to be negative 8. Sorry about that. Negative 8. And you do the radical both sides. And you just have x is equal to 2 plus or minus the square root of negative 8, which would be 2 root 2i. But it's something that you can do fairly fast if you are just doing simple motion across the equation. So I really like this method because I feel like it's something that people can learn to do in their head, as opposed to the quadratic equation, which is a little bit harder to keep track of.